So let's look at the principle of reflection. We have a platform with a light source going through a slit that sends essentially a beam of light down overlaid on our graph paper. So here's a plane mirror placed in that incoming beam, and as I rotate the plane mirror, you'll see our reflection. So here is that mirror again at 45 degrees to the horizontal, and what looks like a 90-degree angle between the incoming and reflected rays. If we construct a normal or perpendicular to the surface of the mirror, then we can understand the principle of reflection. And that principle is that the incident angle and the reflection angle are equal. Right? So the incident angle is the angle that the incoming ray makes to that normal, and the reflection angle is the angle from the outgoing ray to that normal. And again, they're equal. So for every degree of rotation of the mirror, we had 2 degrees of change of direction of the rays because the incident and reflected angles are equal. We can also talk about a deviation angle, which is the angle between the original incoming direction and the final outgoing direction. So another useful concept is the focal point. Here's a curved mirror placed in that incoming beam. And you'll see that as I shift the platform to one side, our reflected light bounces off at an angle. And I'll just trace on the graph paper that light. And there we go. Now, as I shift the platform to the other side, you'll see our reflected light follows a path that intersects the previous line that we drew. And regardless of how I shift the platform, you'll see, it may be a little difficult to see, there's a fixed point that all the reflected light goes through, and that's called the focal point. So here are 3 of those beams overlaid together. We have the incoming parallel rays, and then they are reflected, and you'll notice that they pass through the focal point. We can also speak of focal length, which is the distance from the focal point to the curved mirror. So we can actually have a negative focal point as well. So here the light, instead of bouncing off through a fixed point, it just seems to diverge away from the curved mirror. So for a couple of these rays, we can look at that. So here are 3 incoming parallel rays. Here are those rays that reflect off the curved mirror. And again, they don't pass through a point, so at first it doesn't seem like there is a focal point. But if we consider that those rays seem to come from an apparent source of that light, essentially that apparent source of reflected light still counts as a focal point, and it's negative in formulas, as we'll see. We looked at total internal reflection, and let's demonstrate that with a semicircular disk. So here's changing the direction, and you'll see an incoming ray of light, a reflection, and a refraction. If I consider the flat surface there, the dotted line is the normal to that surface, and then we've labeled the incident rays and the reflected ray and the refracted ray. So as I rotate the disk, I'm increasing the incident angle. And if I continue doing that, you'll see I now have that critical case there, a 90-degree refraction angle. And just a little bit more, and that's it. No more refraction. All of the light is reflected. Total internal reflection. So there's some refraction, now it's gone. And there you have it, total internal reflection.